So now let's take a look at the ARP table. For each node maintains its own IP, its own table called IP map. If you want to check your ARP table, you can use the following command, just like I've displayed earlier on. So the following example will shed some light on ARP tables when host A create a packet destined to host B. Before it is delivered to its destination B, A search into its ARP table. If the B layer 3 address is found in the table, meaning the IPv, the corresponding MAC address, MAC B, is intercepted. It's inserted as layer 2 destination address to the protocol frame. So this is just a simple diagram to illustrate what I just explained. If the entry is not found, an ARP request is sent on the LAN. The request contains the following values: the destination field of the IP Ethernet packets. So these are the various values for the request. As you can see being displayed, we have the host IP address column and the MAC column. You can see the ARP table does not contain the destination IP MAC pair. So let's proceed. So you can use your Wireshark to look at this. So this to do further diving of what we are talking about. So the 48-bit MAC address used as the destination is layer 2. As we all know that MAC address is always on layer 2 broadcast address. The ARP request reaches all the nodes in the broadcast domain. The node whose IP address does not match with the destination IPv, we just dropped the packet because this is not known. So the node whose IP address matches IP_B will respond with an ARP reply to the sender. This is information that the reply will contain. So this is the details information. We're going to do some hands-on sniffing very shortly with our Wireshark and IP dump and TCP dump further. So let's look at the basic ARP. At this point, host A has information it was looking for. MAC_B, you can add this information to the frame and forward the message to the correct node. It will also be inserted in its MAC table for data use. As you can see how this is being displayed, you can see that it's a dynamic. It didn't keep changing depending on the traffic. So let's look at the summary of the ARP used. A host desires to send a packet to another host in the same network. A host desires to reach another host beyond its local network and needs the gateway hardware address. A router needs to forward a packet for one host through another router. A router needs to forward a packet to the destination host on the same network. Let's look at gratuitous ARP. This is how ARP works if one of the hosts in the network asks for it. For our attacking purposes, it's also very important to know that this is not the only way. The so-called gratuitous ARP requests and response are also possible. Gratuitous ARP request, it is a request packet where source and destination IP are set with the IP of the machine that is issuing the packet, and the destination MAC is the broadcast address. Gratuitous ARP reply is an ARP reply that has been sent without being requested, although they may be useful to detect IP conflict or simply inform other hosts or switches of a MAC address in the network. Attacker can use this packet to mount ARP poisoning attack. So let's see this in the next slide. So let's look at it. How this new work. Let us dig dig deeper in how ARP poisoning works. The attack is performed by poisoning the cache of the other host in the network. You have two main ways to mount this type of attack. You can do host poisoning or gateway poisoning. So for the first scenario, which is the host poisoning, the attacker will create a man in the middle configuration between two hosts, transferring data between them. As you can see, there is the man in the middle between the two hosts. So all the traffic from B to A and from A to B will pass through this man. A must be able to forward the packet quickly to keep the system administrator from suspecting. So this guy sat at the middle, and the guy would sniff, capture the packet, and modify the packet and quickly send before the other person gets to know. So the gateway poisoning. The second scenario is one way. The machine that is going to sniff traffic in the network will send gratuitous therapy replies to some or all the hosts in the network, announcing its MAC address as the MAC address of the default gateway for the network. You can see it. So this guy fetch the entire network that is MAC address is the default gateway MAC address. Once again, this is achieved by forging an ARP reply containing a fake IP to MAC correspondence. With this kind of redirection, attacker can get all the data with the foreign destination address and pass to the real gateway. Attacker M should be able to process a big amount of packet or seconds. Unintentional denial of service can occur in the network if M is too slow for forwarding the packet. So that means that attacker was very, very fast. As he gets the traffic, the packet, he needs to quickly forward before it gets noticed and before it causes a denial of service. So now that we have a good overview of how an attacker can mount an IP poisoning attack, let us see which tool we can use to intercept and analyze network traffic. After the following tools review, we will see how to actually attack a network via ARP poisoning. So let's quickly look at the various tooling. The first tool, which is very popular, is Wireshark. In addition to the previous setting, we also want to save our result of the file called ETH, that's called packets. So now let's quickly do a simple demonstration of how the Wireshark works. Let me go back to my machine that seems to have doesn't have much going on with this guy. So let me try and bring up my other systems. I want to bring up my other systems like OWASP broken web applications. While the machine is coming up, let's quickly check the IP address on this 10.9. Okay. So for the OWASP booking web application, the username is root and the password is OWASP BWA. So after logging in, let's try and open up the URL for this application, maybe on our host machine. One 192.168.168. Dot 40.145. This is a machine. So on this machine, I have quite a number of vulnerable web application that we can work with. But I'm not interested in attacking the web application. I'm trying to bring up a new interface and see how it works. So let me see if I can ping this guy from here, 192.168. From this machine. You can see as activity is going on, you can see that it's capturing the flow. So this is the MAC address. Initially, the machine is information is empty. Just want to have so that you have a look at how this works. So let me try and ping another maybe my host. Let me ping 172. That's my host. If I do that, so you can see that it has captured more IP, more interfaces, and each of those interfaces with their various MAC address. So that's how you use so let me look at my my wireless interface. I think I will have. Let me see. Interface 192.168. 56. .56.1. As I'm doing to reach out, it will keep adding those. So my machine, let me see. This is the IF config, right? IF config domain. Okay, this has only this interface. Interface 192. Let me see whether this interface is captured on my Windows machine. I think it should be captured, right? Yeah. Okay. So you can see that interface. So that's how to use ARP to sniff the MAC address to see what is going on or the connection at the MAC address. So with your Wireshark, you can also use your Wireshark to sniff this packet on the read type. So let's open up our. I try as much as possible to open different interface so that what we are discussing will make more sense. So let me open up my Wireshark from here. You can come to under sniffing and click on Wireshark, or you type Wireshark or a command on the terminals. But for now, I think I only have one interface on my network. Let's see, 180, but if I want to capture everything on the network, I will click on any so that it will be capturing every interface. So you double click. And wait for it while it come up. So let me do a live traffic. Let me just try and do something on this network. So you can see immediately I've sent in the traffic. I'll see those traffic. The live traffic. You can filter based on the protocol. If you want to display all the ARP protocol, you type ARP. If you want to display all the HTTP protocol, you type HTTP. If you want to display all the ICMP protocol, 1, 2, 3, 4. If you look at the ping, I stop it at earlier. So that's how you can leverage your Wireshark to do the live capturing. In lesson 4, under when we talk about we also do some live capturing with our Python module, especially we use Python to do some capturing. So using this CAPI module on Python. So the reason why we are releasing this so that you can be familiar with the various ways by which sniffing can be carried out. So that it will also help you to be able to do, because if you understand the basic, you understand the basic, it will help you to be able to you write a custom script based on what you want. So doing this, we display only the packet sends. So you can, for example, I use HTTP filter. So if I want to do a further deep dive, for example, let's presume that, okay, I think I've launched my some of my vulnerable application right on my host. Let's presume that I want to deep dive, or let's presume that, okay, let me just see what is going on here. There is this vulnerable application called Mutra. This vulnerable application called aptoromutra.com. Let me see whether I should be able to capture those specific HTTP traffic. So my system is couldn't log on. Let's see. Oh, my internet is crazy, right? All right, so I don't know whether you can see whether I've shared my screen. Okay, I think my screen is shared. I'm trying to log on to my application at aptoromutra.com. Okay, I think let me log on again. All right, I log on as admin. So let me come back to let me see whether I can see the HTTP packets. I think this is the packet. This is where I initialize the packet, right? If you want to deep dive into the packet, click on follow TCP stream. So you can see that's the HTTP packet. So let me come back to HTTP. So this is where I establish a logon, right? This is where, okay, this logon was successful. You want to deep dive, you can look at the packet, so you can do a whole lot. This is where I made the request. As a request. But if I want to be more specific, I can say frame contain to ultra.com. Hold on. I want to be sure whether it's capturing this. Okay. Let me try this in this let's try it to ultra. So I'm trying to, okay. You can see it as maybe packet. So this is the UI calling the login parameters. If you want to follow the stream, you click on TCP follow stream. So if you want to follow it, why? So you can see, because I'm using an HTTP protocol, you can see that the packet is not encrypted because an HTTP protocol. I can see the credentials being sent in a clear text. So with Wireshark, you can use Wireshark to sniff any packet in your network and you to sniff any packet. So if you are connected to the same switch, anybody that connected to that switch, you can sniff all the whatsoever thing that they are doing. So that's why it's always important to encourage the use of encrypted, make sure that you use a level of encryption that is very strong enough. So what we just did, I will give you us like 10 minutes. Can we try the same thing with Scapy on Python and try and use the sniff functions, just like we did in our previous in lesson 4. So you can do the same thing and do a deep dive to a specific protocol. So just log in your or you can use any of the applications here. Let me open up another application that you can make use of. Can make use of